Good morning, everyone. Shaheen is here. This week, we started two important topics. The first one was friction, not much important for structural design in terms of the building, bridges. Friction is not playing a great role over there. But the second topic was about the truss structures. So truss structures are very common. They are being used in bridges. They are being used in um, cranes, gantry cranes, which are used in tall construction buildings and to move around the heavy constructional material for a building. They would erect a very tall pillar with a gantry. So that is to displace the heavy constructional material between different stories and all that. So yes, that's a very efficient design. The reason is it uses the minimum amount of the material and the ratio of the strength to the weight is quite high because truss structure is hollow. It only uses material where it is needed. If you would have wanted to construct something from solid structure, that would be way more expensive, more using material. So that's the justification of why trusses are so important. So what you need to know is a truss is made of two common components. The first one is a pin. The second one is a two-force member. So I'm sure you've done these Lego things, you put things together. So think of a truss structure like a Lego. There are pins, there are two force members, and you push pins inside the one end of the two force member, and you can pass the pin through several or two, at least that's two, right? So that's why we call this a pin joint structure. So it is essential you understand how this truss is distributing the load before you can analyze it. The loads are only applied to the pins. There is no way you can apply load between two pins. So what I'm saying is in a real situation, if that is a two force member, I'm just exaggerating things for you to better understand, right? So at the end of each two force member, there are holes. So that is to let the pins go through. I mean, in real life, maybe that's not the case. You have a gusset plate, having them riveted together, but this is a simplified one. This is the simplified one, and it's good enough to tell you how the forces are distributed. Imagine that I have another member like this one pinned to this. All right, so I put these two together, and maybe I put another one. All right, can you see now we managed to put three two force members together, and when I put a pin through this one, how the force is applied? The force is not applied to this member, or that member. The force is taken by the pin. So pin is acting like a distributor. So whatever force is applied here, what happens to the force? When you apply a force here at the pin, um, when you apply a force at the pin would distribute the load, and each individual member can only take the force axially, right? So imagine this is a channel with a water. So the water comes at a junction, and the junction distributes water only axially. So it is wrong if you apply the force here. It is wrong if you apply the force anywhere but at the pin, because what it does is it starts to bend the member, and the minute it starts to bend, it is not a two-force member anymore. Okay, so imagine these are made of spaghetti. I told you before, spaghetti, you can pull this or push it a little bit without breaking, but the minute you start to bend it, it breaks. So that is the basis of when we do the method of joint. So here I decide to cut that structure like so. Yeah, when I apply method of joint, what happens? This method of joint is a free body diagram. That's an enclosure which is cutting through the members. The forces are internal, but the minute you cut them, you have to expose them. So if I cut this one, what happens? There's a simplified shape would be like that, right? So you have one force acting here. This is the force. And then every member you cut, these are going to have either tensile force or compressive, because the member becomes longer or they become shorter. They cannot change their curvature. So, well, we sometimes we can anticipate whether the member is tensile or compressive, but in general case, we assume they're tensile. If I put the forces like this, these are making my member longer, and therefore these are, I have assumed all these forces are tensile. So this is wrong. Definitely some of these has to be reversed. We only know it after the solution is complete. So by getting a negative number, we realize that something was wrong assumption. All right, so that is the method of joint. And with the method of joint is a simple method, but it's a limited method. It can only handle two unknown at a node. Why? The reason is, with the method of joint, you notice all forces are passing through one single point. So that free body diagram does not have any capacity to rotate. It can only, you can only impose no translation in X, no translation in Y. But the minute you start no rotation, all you get is 0 equal to 0. That's not useful information. So this is the limitation of the method of joint. It can only handle two unknown at a time. So in this case, if all these three internal forces are unknown, we cannot solve. So this requires a bit of cleverness, strategy. So you look at the structure and you have to decide, okay, I cannot apply method of joint at this one to begin with. Is there another joint which I can start with? Because if you start with another joint, then you find some forces. Those forces are shared. I mean, whatever I find in this member, that is the very same forces apply to the second one, right? So once I solve this joint, the very same result, I can transfer it to the next node when I'm applying method of joint to that. You notice what I say? So you have to have a strategy. Okay, I deal with this node first, that node second, this node third. If you change the order, the problem is not solvable, because you are attempting something which is not solvable. 3 unknowns, 4 unknowns, two conditions, that's not solvable. So you have to choose how to start. And in some cases, you might need, before doing the method of joint, you need to find the reactions. And to find the reactions, what do? We solve the entire structure. Then you solve the entire structure, that gives you the reactions. So yes, the entire structure can impose three conditions. Because it's a rigid body, the forces are not colliding at one single point. The free body diagram has capacity to rotate. So then you have three conditions, you can handle three unknowns. Okay, because of the limitation of the method of joint, I mean, this is handy. Depending what you are trying to find, maybe that's the best approach. But sometimes you want to find forces and method of joint is not applicable. That is why we introduce a second technique. That technique is called method of section. So method of section, I think I would postpone that introduction next week. For now, we just try to do more practice. Any question before we start? All right, let's see what page 254 has for us. So these are some fundamental problems, and so we discussed that in truss structures, it is common to have redundant member. Redundant member also, they are called zero force member. Anyone remembers what the zero force member is? Shah, can you tell us what is a zero force member, redundant member?
If two forces are like forgot the name, two like joined with another one, so then
So you're talking about the rules, about the condition, but the definition is for a given loading, maybe some members are not needed. If you remove them, they won't change anything. So they only make the problem simpler. So example of that is here in fundamental problem 5151, DB is a redundant, it's a zero force member. In fundamental problem 3, AC is a redundant member. In 6, DB is a redundant. When you remove it, also you notice that BE becomes also redundant. All right. So these are how we can go about even with 5, DC and CB are redundant member. It's very recommendable you understand the rules, so you identify the zero force member where you see them, because that would reduce your effort in solving the problem. Um, so just tell me which problem you prefer, something simple, medium, difficult from this page, and we deal with that together. So Porty, which one should we go with? This one? Medium. All right, what about number 4? Yeah, number 4, there is no zero force member, but this problem has a condition of symmetry. Condition of symmetry. All right, so this is a very conditional thing. I mean, you have to fully solve the problem, not only to find the forces, also find out which one is in tension, which one is in compression. And when you do your practical starts maybe next week or the week following that, and in that you have to find out which member is tensile, which member is compressive. That makes a big deal. Why? Because some material behave differently under tension and compression. Example, that's concrete. Concrete, it takes huge amount of compression, but the minute you try to apply tension, it breaks. So it is important to find out whether the member is in tension or compressive load. So in this problem, let's understand what the problem is saying. It says none of the members can take 2 kilonewton, more than 2 kilonewton in tension, or more than 1.5 kilonewton in compression. So the first thing we find is we have to identify all forces in terms of P. In terms of P, we assume that P is given, right? That's a starting point. So I find the force inside AC, CB, and AB in terms of P, and then also I have to identify whether these forces are compressive or tensile. So I have to check one by one which one is the bottleneck. The bottleneck is the one which has the compressive load, because it can only take 1.5 kilonewton. So let's take this. This is not as easy as it looks, right? All right, so it's easy to find the reaction forces, isn't it? I can find the reaction forces, and reaction forces are, all right, I know that B can only take vertical load, and therefore A cannot have any horizontal. I mean, this is generally speaking, that's a pin. Pin has both components, but because of the symmetry, I easily, even without doing any calculation, I know that AY is P by half, B is P by half. That's because of the symmetry. All right. So the smartest thing to do is, I mean, I can apply method of joint at C, but even smarter is if I apply method of joint at A. Why? Because if I apply at A, that gives me the entire solution. Then I know not only the force in AC, AB, but because of the symmetry, AC is equal to the CB. So one single solution gives me everything I need. So let me apply method of joint at A. Method of joint at A. All right. So what it does is, all right. So generally speaking, you have to include AX. All right. The only horizontal force is AX. So therefore, AX becomes 0, right? And then now let's take rotational condition about A. All right. If you take rotational condition about A, that is P by P times 1.5 is equal to By times 3. All right. If you divide both sides by 3, you get Py equal to P by half. Also, you can do the same, taking rotation with respect to a B, that give you the same thing. But I mean, just with experience, you know that some problem, even you can skip that and find that by just rule of thumb. All right, now I would like to make a free body of method of joint at A. So how does it look like? It will be one force here, one force here, and I already know that AY is PY2. Anyone can help me to label these forces? What should I label them? This one, what should I put as a subscript? F, AC. That's how we label them, right? F stands for force. AC shows that this force is from A to C, the force member. What should I call this one? That is FAB. All right. Now, to solve this problem, um, the easiest way is to go with the method of triangles. So the noun force is P by half, and one force is by parallel to FAC, and one force is parallel to FAB. And this one is half P. All right. Here, I assume that both forces are in tension, but we know that this is not feasible. Okay, so let's see what is the, I mean, it is more feasible to have FAC at compression, AC at compression, and AB at tension. Why? Because just imagine what happens to those members. When you apply the load, AC would be trying to become shorter, right? So that is why I put FAC in compression. And because of that roller, B tends to go toward the right. That makes AB under tension. So this is, I know that FAC is compressive. This one is tensile. So compressive, compressive, tensile. All right? Can you visualize that you made a structure like this one and then you're pushing it? What happens to the AC? AC becomes shorter or become longer if you try to apply this one. You made a wooden structure. It has a wheel. It's free to move at one leg. The other leg is fixed. So you push this one. What happens here? Are these verticals going to be shorter or longer? Shorter, because they tend to become shorter. They're under compression, and the horizontal leg, because of that wheel, tries to escape. That becomes longer tensile. All right. What is the angles? That angle is 30 degrees. This angle is 60 degrees. Okay. Now, FAC times cos 30 is equal to P by 2. And cos 30 is equal to root 3 over 2, isn't it? 30 cos, yeah. So that is root 3 FAC is equal to P by 2. So you cancel these ones. And then FAC is equal to 1 over root 3 P. And what about FAB? So um, FAC times sine 30 is FAB. That's a, you can apply the sine rule. You want me to write the sine rule for you? That's easy. You just write FAC divided by sine 90. Sine 90 is 1, right? So sine 90 is 1. That is equal to um, half P divided by sine 60. So sine 60 is half, right? Sorry? Sine 60 is half. Sine 60 is, yeah, that's Root 3 over 2. You're right. Yeah, yeah. 60 sine. Yeah, you're right. So that is root 3 over 2. So therefore, you get FAC equal to 1 over root 3P. That's correct. And then also this is equal to FAB divided by sine 30, which is equal to FAB divided by half. And then that is FAB is equal to half FAC, which is FAB is equal to 1 over 2 root 3 P. So now we know that FAC is in compression. So if that is in compression, the maximum load it can take is, so here I say compression. So therefore, FAC max is equal to 1.5. Is this Newton or kilonewton? Kilonewton. So 1.5 kilonewton, that is P equal to root 3 times 1.5, which is 3 over 2. All right. So that is the maximum P according to the compressive load. And then we have to find the maximum P when we are studying the tensile load. With the tensile load, which is this one, tensile. So FAB maximum is equal to 2 kilonewton. So according to this one, the maximum P is 1 over, the maximum P is 4 root 3. So which one is larger? Is it, this is larger, right? So if I apply that load, definitely the compressive load would break. But if I apply that load, the tensile won't break. So here you have to be conservative. You have to keep the weakest member of the family, right? So this is like you're pulling a chain. One of the chain is weaker. That one breaks first. So this is the maximum load you can apply. The lowest load is the maximum you can apply. So let me just zoom out if you want to. All right, next question. Next question, we move to page 255. Yes. FAB is in terms of P, that is 1 over 2 root 3 P. No, that is, let's find from here, FAB and FAC. Okay, so if I take that portion here and then manipulate that middle part, what I get is sine 30 is half and sine 60 is root 3 over 2. Okay, so that is half P divided by sine 60 is root 3 over 2, and that one is equal to FAB, and sine 30 is half, right? So you cancel these twos together. That is FAB is equal to 1 over 2 root 3P. Okay, just on a general note, so this is a channel that is called measuretronics.com. Okay, if you go to this channel, there are a few playlists. One playlist is called mechanics of a structure. If you go to that measuretronics.com.au, go to the mechanics of a structure. I try to put all recordings here such that you can browse them on mobile. Collaborate also sometimes is not convenient. All right. So far, I think I uploaded until yesterday. I tried to do that at most in 2 days, so you can see the latest recording here. All right.
Is it open for all or for only management? Is it open for all or only management?
Oh, yeah.
Absolutely fine.
All right. Now we do problem 5-2. Okay, so now if that is compression, the maximum FAC is 1.5 kilonewton. If you put that equal to 1.5, you find P. That is the maximum P you can apply. And then this is tensile, it can only take 2. If you plug FAB equal to 2, you find a different P. So you got 2P. Which one is the smallest? The one which is smallest is safe to apply to the structure, because you apply the larger load, maybe the tensile would survive, but the compressive won't survive. All right, to solve this problem, you tell me what is the strategy, what is the best strategy to solve this one. Where should I start? Can I apply method of joint? Can I start with method of joint? If I start at D, how many unknowns I have? 40. If I start method of joint at D, how many unknowns? D. Three unknowns. Yeah. Method of joint can only handle two. So that is not a good start. If I apply at B, how many unknowns? Three. Is not solvable. If I apply method of joint at A, how many? 1, 2, 3, 4. Because A has two reactions. Yeah. And if I apply method of joint at C, I will have 1, 2, 3. Not solvable. So definitely you can't start this problem by method of joint. You have to start it with something else. Later, maybe you can do a method of joint. The other technique that we know is to solve the entire structure finding the reactions. So let's try to find the reactions. So if I release the supports, these are the reactions which are exposed. And I know that this angle is theta. How do I know this angle is theta? Because if two angles are mutually perpendicular, they're equal. So therefore, that is the reaction of C. I call this C cos theta. And I break that also into another component, C sine theta horizontal. So now my problem, that is AY, this is AX. How many unknowns are there? Only three. C appears two times, but still that's one unknown. So let's try to solve that. I think the easiest one is to take rotation with respect to the A. If I take rotation, I think I have to reduce the size of this one. All right, I start with rotation with respect to point A. And positive direction is counterclockwise. That is 4 kilonewton is a negative rotation, minus 4 times 2. 3 kilonewton is a negative rotation, that is minus 3 times 1.5. And yeah, this one, the direction of arrow is like so. These are direction of arrow. The vertical component is make a positive rotation, that is plus C cos theta multiplied by 4. And then the horizontal one doesn't make any rotation because it's passing through A. Did I miss any force? I think I included all. That is equal to 0. So theta is equal to 30 degrees. So theta is 30 degrees. That is minus 8 minus 4.5. plus cos theta. Sine theta, if you draw the line of action for sine of theta, that is passing through A. It won't make any rotation. Only this one make a rotation. That passes through A doesn't make any rotation. All right. So cos 30, that is root 3 over 2, right? That is 2 root 3 c equal to 0. All right, from here I get 2 root 3 c is equal to 12.5, and then c is equal to 3.61, and the unit is kilonewton. The next step, I apply method of joint at C. If I apply method of joint at C, this is what I get. That is FBC or FCB. That one is FCD. Okay, easiest way to solve that is by method of triangle. So I need to find out that angle. This angle is 435. 435. Right, so this is 435, and I get that is.
So why is it 45?
I just double the sizes. This is 2 1.5. If you make it 4, this becomes 3. So a right angle is 435. So this is 60 degrees, and I know the magnitude of this one, that is 3.61. So let's find out the angle. Tan of 3 over 4. 3 divided by 4 inverse tan. That is 36.86. Let me take this away from 90 degrees, or take it away from 180. that is 143. So this angle is 143. And then this one is FCB, that one is FCD. So how can I solve that? By the method of triangle. So that is 3.61 divided by sine 143.1 is equal to FCD divided by sine 60. So FCD is equal to sine 60 divided by sine 143.1 multiplied by 3.61. That multiplied by 60 sine multiplied by 3.61. All right, so FCD is 1.88. Yes, let me write this one. All right, I applied method of joint at point C, and then we calculated the reaction. The reaction was 3.61. So these forces, FCD, FCB, one is horizontal, the other one is along that member. I know the angles. So three forces in equilibrium. One way of solving that free body diagram is by constructing a triangle. You can resolve the forces in x and y. That needs you to solve two equations, two unknown to solve. But in cases like this, it's easier to construct a triangle. So this triangle, you follow this triangle? No, this you don't. Okay, so I draw three that is parallel to here, which is 30 degree with a vertical line or 60 degree with a horizontal line. That I construct. And then this one is parallel to this triangle, which is making, so with this angle, you get 38.86. So 38.86, take away from 180, that you get a 143 angle inside. These are back to back equal angles.
How can you draw it? I mean, FCD is like horizontal, and 3.61, but we just have to be
So this force, if I extend them here, you can see them clearer. So let me extend. That is the line of action for this one, right? This is the line of action for that one. Is this 30 degrees?
So it could be 60 degrees because
This is 30, that is, so let me draw that triangle again. Let me draw that triangle again. So do you see, is that okay? That extensions are okay? All right. So in that sense, I have one here, and one horizontal. All right. The left hand one, that is, This is 30 degrees here. And what can we say about this line? Oh, what can we say about this line? This line with vertical, that is this angle, right? So that is this one, which is 4/3 inverse tan. $53. Yeah. Yeah.
You see this one here, start drawing here. So this is 90. So this is 60, 60. So this is straight line here.
Why 60, 60? Because they are not equal. That's 1.5. This is that angle is 38.86. Yeah. Yeah. If that's 38.86, the other angle is 53.13. Take away from 30. So this angle is 23. This angle is 23. This is 23.1. And 23.1. And this angle is 38.86. But I know the magnitude of this one. The magnitude of this one is how much? 3.61. So let me clean that portion here. I have to redo it. I think I was wrong. So I'm drawing that triangle larger here. Okay, can you follow this triangle? That is, this is FCB, then the horizontal is FCB. And that one is FCD, is it? All right, so we can solve this triangle, can't we? All right, how did I get that? Is right. So here I have a triangle with this triangle. What is that angle? This is 38.86. And what is this angle? That angle is from here is tan inverse of 4/3. 4/3 tan inverse. So that is 53. 53 you take away from that 30, that becomes this angle, which is 23.1. So this is 53.1. This is 50. 3.1, but you have a 30-degree angle here. So take away that 30 degree from 53, that give you 23 over there, right? Yeah, trigonometry is never easy. Trigonometry is never easy. I remember in my VC year, that was a revolution. So my trigonometry teacher gone, I don't know where, to jail or somewhere, and the entire class we had to study the trigonometry ourselves. And then the day of exam, everyone wanted to go on a strike. Say we are not going to take exam because, and I betrayed them. I went and sit in the exam, so they strike just didn't work. And I think I got a full mark. Without teacher, we did the trigonometry. So that's the only subject I was, um, yeah. Anyway, trigonometry you only have to practice.
Where are you from?
Sorry?
Where are you from?
From Iran. Yeah. Revolution is never good. Revolution only make things worse. All right, so this triangle you can solve, and that give you the forces FCB and FCD. And once you have them, the next step you can apply method of joint at B, because then having FCB, you transfer that to the next free body diagram. That is, if I do the method of joint at B, that's what you get. So here you find FCB, whatever that FCB is. Here you have 4 kilonewton applied here, and then that remains FBD and FBA. Only two unknowns. Method of joint can handle two unknowns. And also we know the reactions from the solving the entire structure. You find the reaction, and then if you apply method of joint at A, that is what you get. You know AX, you know AY, and then the only unknowns are FAB and FAD. Two unknowns, method of joint that is solvable. And finally, when you reach to point D, you already know all the forces. So why is that for? This is to check your solution. When you go back and apply method of joint at D, you already know FDC, FDB, and FDA. But then, if that tally ups correctly, it means your previous step solutions are correct. That's a checksum. This is a checksum. All right, let's go to page 254. And here, I think we already did some of these. 3, 4, 5, 6. 3, 4 we already did. 6, yeah, let's do 6. All right. Can you see the numbers from there? Or is that large enough? Okay. So this might seem difficult, but it is not difficult. You have to simplify the problem. Natasha, how can we simplify this problem? Nguyen, how can I simplify this problem? dB and BE are 0, right? So that would reduce the problem to something much simpler. All right, now with this problem, you have two forces acting here, and then we don't need to label these 2 points. That's the very important thing. When you remove these two members, ED and DC, they merge together. They become one single member. And also the other one is AB and BC, they merge together. Now you only have FAC. So can I apply method of joint right at here? Yes, we could. So that is method of joint at E. That is what you get. So this is E, and I have 45 kilonewton here, 60 kilonewton here. And how should I label this one? Anyone can help me with labeling that? FEA, and this one should be labeled as FEC. There's no ED anymore. It's EC. And this angle is 60 degrees. All right, easy. So to find out FEC, all I do, I write net forces horizontally equal to 0. That is 45 positive minus FEC.
So
Yes?
how did you know FTC is problem?
You just assume. If you take it in the opposite direction, eventually you get a negative and you correct it. This is just by rule of thumb. I feel that if you push this down, this is going to be under compression. But if you can't visualize it, absolutely okay. Just assume everything is under tension. After finishing the solution, you find it wrong. You have to change the direction. So FEC multiplied by sine 60 is equal to 0, and sine 60 is half, is it?
No, root
Root 3. Okay. So that is 45 minus root 3 over 2 FEC is equal to 0. And then you get FEC is equal to 90 divided by root 3 kilonewton. And then I can calculate FAE. So net forces vertically equal to 0. That is minus 60 plus FEA plus half FEC, which is FEC cos 60. So that is plus half FEC is 45 by root 3 equal to 0. So FEA is equal to 45 divided by root 3 So FEA is 34.02. And then is this compressive or tensile? This is compressive because in the, and this one is also compressive. All right, now we found two forces, and the next is you solve A. Method of joint at A, that is AX, AY, and vertically I know that FAE under compression, this was 34. And horizontally, that is FAC. So from this free body diagram, I can only find AY. AY is equal to 34 in compression, or upward kilonewton. But I can't solve the equilibrium of X equation from here. So therefore, I think we have to go to method of joint at C. So let's do method of joint at C. Okay, if I apply method of joint at C, I would have a vertical reaction. This is C of Y. And also FEC. FEC, we already calculated that this was under compression. This is 90 over root 3 kilonewton, and the angle is 30 degrees. So then there will be a horizontal force FCA. So FCA CY. Two unknowns, this is solvable. So how can I solve this? That is net forces horizontally equal to 0, that is FCA positive negative plus 90 over root 3 multiplied by cos 30.
So we don't have to construct a triangle.
Sorry?
We don't have to construct a triangle on that.
You can construct a triangle, yes, you can construct a triangle. But even Cartesian is okay. 90 root 3 multiplied by cos 30. Cos 30 is root 3 over 2. All right? So therefore, FCA becomes 45. 45 kilonewton, and that is under compression. This is under compression. And now that I know this force, I can go back to the previous free body diagram, and here AX becomes also 45. AX equal to FAC, that is equal to 45 kilonewton. So now we solve the internal forces in each individual member in the structure. Let me bring all these together so you can take a snapshot if you wish. Let's make it a bit larger. 55, 56. Okay, 5-4 is a difficult problem. Do you want us to solve this together, or you prefer something easier? You want to think about 5-4? I can tell you the steps. 5 minutes is okay. Just think about the strategy. Where do you start? What would be the right start and the steps?
Which question is our exam standard?
Exam
Exam standard.
for mid-semester exam, I think that is um, friction and machines, and yeah, truss included, because these are pin joint structures. Go on.
After our break, when we come back, we're gonna have experiment.
You want a break?
After,
What do you say?
because we're gonna have break 17, 16 April. So when do we start exam?
Have to look. I have to check the timetable. Let me check this together. All right. So here, that is, you go to the syllabuses, and here that is your unit guide. All right. So week 5, and you go to the break week starting 3rd of April. When you come back, the Monday you come back same time as your lecture. Your lecture was 12:30 to 2:30, right? You come on campus. I take you to computer lab, and the test is on Canvas quiz. Canvas quiz is very similar to the Pearson, but it's not difficult. Pearson has a graphical language. So what was the question?
So like we have to take this to break in like we come back.
Yes.
So don't you
That's the best thing could happen to you. I mean, imagine if I do that before the break. That's you don't have time to prepare. So that give you 1 week to prepare for the exam.
Sir, will not you give us any revision class?
Well, in class, if you engage, I give you some chances to get bonus marks. I mean, so far, I think few people have got it. 40, you got a bonus mark, and who else? Just remind me. So if you engage in the class, yes, you get bonus mark for that. And don't worry. I mean, this term, everything is simplified. Even I made 30% for your practicals. Practicals are not difficult. These are fun. Um, we used to have something, a terrible prac that was a structure you have to assemble. This was half the size of this door, the size of the door, and all measurements were wrong. It was very frustrating to do the things, write the report, and eventually nothing would match up. The measurements, calculation didn't match up. So I made two um, practical from scratch. These are, you put together some truss structures like Lego, and then one member is magnetic. So the tensile member is magnetic. When you increase the load, the magnet would break. So you can measure how much that magnet can take. That's the strength of the member, and you do a calculation. So this is give you a very close match, and believe me, that's something fun.
So will you give us any practice paper so that we can take it in our break time?
I give you
Any practice paper so that we can take it in our break time? Revision paper I can take also.
what we do in class exam. You don't expect anything. I mean, even here we do some very tough questions in exam. You get something doable in exam. I mean, this is only 2.5 hour exam. Can be difficult. All right. So let's go back to the question, and I would like to know how you proceed with the double Caesar structure.
I just have a question, sir. Like, will you provide solution papers?
Say again your question.
Like the solution table?
Solution paper.
Yes.
What is solution paper?
Like for example, the solution you take and you get the solution. Yeah, you used to
Exam
do.
preparation. The best preparation is to watch these examples. You are just doing demonstration, right? It's a very minimal theory. All theory you have to understand here is net translation zero, net rotation zero. Vectors, you already know that. It is a almost minimal amount of the theory, and everything we do here is just a exam preparation. All right. All right. So this is a challenging question, and if anyone can tell me the steps.
Can you get the previous year exam question?
No, because they were online, and yeah, online they're being generated random. I mean, the number would change, and then one thing in the exam, uh, you would get the same question with different numbers. You know, if anyone can tell me about the steps here, I give them 2 bonus marks for the exam. Do you want to try your chance?
Yeah, here we have to find no post member like here.
I help you. Can we start with method of joint? If I apply method of joint at B, there will be 3 unknown. C, 3 unknown. A, how many unknowns?
Five. Five.
5. E, how many unknowns? 3. At E, no, P is given, right? So how do we do this? Can you do entire structure? Okay, entire structure. Even without doing it, this is magic. I tell you that is P, this is P by symmetry. All right, so that is easy. You just tell me one more step, and I'm happy to give you 2 bonus marks for the exam. Just tell me that's to um, just break the challenge, make it easy. Do you find any zero force member?
How can we adjust that if the member is
Sometimes you can make a guess based on experience. If you can't guess that, that's okay. Start with assuming everything is under tension.
What do you mean by the rotation control?
So here you have to tell me the next step. I told you that these are going to be reactions, P, P. Obviously that fulfills the vertical translation, horizontal translation. You tell me what's the next step, and you get 2 bonus marks for the exam. Point of rotation about where? I mean, before point of rotation, you have to tell me what free body diagram. Do you want to use the free body diagram for the entire structure? Why? You already took the entire structure and got the reaction. So what free body diagram you are talking about with the rotation? It has to be a method of joint, because I haven't told you about method of section. All right, let me give you a hint. I'm very keen to give you bonus mark for the exam, all right? So my hint is I'm applying method of joint at E. Let's see what happens. First of all, this problem is symmetric. Whatever I find, that I can duplicate on a counterpart component. So with point E, there is a given force. P is not unknown. I know P. That I assume this is under, well, if that's under tension, should be other way, but doesn't matter. I'm just making some assumption. And one force here. So that is P. That help me to label these forces. That one is F. What should I label this one? EF, right? What should I label this one? FEA. And what should I label this one? Okay, tell me, is this free body diagram solvable?
Yes, because FEC can cos 45 plus FEF is equal to FEF.
Well, this is not fully solvable, but that is solvable enough to break the challenge. I mean, you know that FEF, no, you don't know anything about FEF, FEA, but vertically, that is all you need. It is partially solvable. If you solve that partially, that would give you FEC. And if you have FEC, what happens? With FEC, you bring FEC here, and then method of joint here, 2 unknowns, that is solvable. All right? All right, should I give the bonus to Porty or? No, Nguyen. All right, so that was the challenge. That was the hint. And now we go to 56. Five 10. Do you find 0 force members here? Two letters.
D, E, and D, C.
D, E, and D, C. Yes, they are zero.
So D in the force, right?
E, D, and D, C. They're zero members. Okay, so this one, this is zero, that is zero. And then you can start method of joint around this one. Yeah, Firefox, since yesterday they changed their browser, they claim you can annotate using Firefox, but this is not working well. So I have to snapshot and take it elsewhere. Yeah, interestingly, with mouse it works, but the digitizer doesn't work. So then you find these two forces here. You have that force. This is zero. Next step is, I think, yeah, that is equal. This is P2. And let's take question number 16. All right, this question, let Ahmed come back. I want to be fair to everyone. Yeah, this question could be examinable. Can you give it a go? Try. I mean, if I ask you find the force in BC, it takes a very smart student to do it with the minimum calculation. Can you find out FBC, the minimum calculation? So, Ahmad, what did you miss? This question might be examinable.
Sorry?
This question
Yes.
could be examinable for mid-semester test. And I wanted everyone to try finding force in BC with minimum calculation. So in a very smart way, you want to find force in BC. not doing too much calculation. All right, for the reason I said, I want you to tell me how this problem is solved. Unless I hear from you the solution, you won't hear it, the solution from me. Okay? So feel free to discuss it. I can just give you a hint.
Or you can give us a little more like solution. You can give us
Well, um, yeah, that's a valid point. Just tell me how you think it's solved, and I try to offer something.
first down the method join D,
Which one?
the method the method join D.
At D.
Yeah, I found the answer at D by so C is one, CD.
So first you find CD.
Yeah,
Is there a simplification you want to do before that?
maybe CE as a what number?
Maybe or for sure?
For sure.
For sure. If that is zero force member, how does it impact calculation of BC? All right, I leave you to have fun with this problem. Hopefully you find out your way in solving it. Um, let's finish the roll for today, and I think we've done enough. So Natasha is here, Nguyen here, Shaisal, Ray, and Ahmad is here, Nijil here, and Shah here, Horty here. Okay, so what we did today, we demonstrated examples applying method of joint and finding the free body diagram, solving the free body diagram for the entire truss structure. Next week, we start with the third technique for solving truss structure, that is method of section. So by end of this week, make sure you do enough practice for solving entire truss structure and method of joint, including the strategy, how to do the sequence of free body diagram, starting from the right place, such that you can either find all the individual forces or those which are specifically asked in the assessment. Any questions? Thank you very much, and I look forward to see you next week on the lecture.